Hello everyone. So let's get started with another very important topic of paleontology, that is index fossils. So index fossils are nothing but a type of fossils. They are normal fossils which we talked about. The remains that were preserved in the rocks and all. So they are actually fossils. But the different thing about these fossils is that these are the fossils of widely distributed organisms that lived during only one short time period. Alright, so these are actually those fossils whose geographical extent was large. But when you talk about their geological extent, it was short. They lived only for a short span in the geological period. So these are actually those fossils who lived in a widely distributed area, those organisms which were distributed in a large geographical area, but they only lived for a short time period in the geological time. Okay, so there is an image. It is an ammonite. Okay, these are the fossils and they are considered to be as the best type of index fossils. Why? Because they were most widely used. They were found in abundant, they were widely distributed and can be easily identified at species level. We'll be looking at how these index fossils are actually categorized. Okay, see here, look at this image. At first strata we are finding some sort of fossils, and the second strata we are finding some other sort of fossils. See, look here. This is the location first. In the second location we are finding only strata A, B and C. In the third location we are finding only first strata. In the fourth location we are finding A, C and D. B is missing. So this is actually what it is saying, that there is a geological column. Okay, there is a geological column where you'll find different ages of stratas in which different fossils existed in different geological times. Looking at the definitions of index fossils in the more particularized manner, we find that index fossils are any animal or plant preserved in the rock record, same as fossils. Okay, but what's special about them is that in the rock record of the earth, that is characteristic of a particular span of geological time or environment. So they're same as the fossils. They are actually the animals or plants which were preserved in the rock, but they actually have a particular span of geological time or environment. Now, a useful index fossil. How we'll find out that this index fossil is useful? Okay, so these index fossils must be distinctive or easily recognizable. What we actually have to find out is that there are different stratas, different rocks or something. We have to actually find out that what geological time it existed. How we'll find out? By the presence of fossil in that strata. Alright, so it should be easily recognizable and it should be abundant. It should be widely distributed. That I just told you, the geographical distribution should be wide, but the geological distribution, the range of time in which existed, it should be short range. Okay. Now these index fossils are the basis for defining boundaries in the geological time scale. They only actually tell that this is a fossil A, it existed for 300 million years. Okay, so there's then fossil B, then it existed for another 400 million years. Alright, so just before we saw now, there is a geological column. So here existed A, here existed B. So if the age of this fossil is 300 million and this is for 400 million years, and here is C saying it to be 600 million years ago. So we can say that the strata C, it is 600 million years ago old, and this is 6 plus 4, 7, 8, 9, 10. So it is 1000 million years ago old, and you add another 300 million in this, then it is 1300 million years ago. So I mean, this is just an example I'm telling you. So in this way, we actually, with the help of these index fossils, we just define the boundaries of the geological time scale. This is just an example I just told you. So I was just going to, try to explain you that how these geological time scale boundaries are defined on the basis of index fossils and also for the correlation of stratas. Alright. Now, in this slide, let's have a look what are index fossils. As we have already seen, fossils that defines and identifies geological periods. How they define it? Because they existed for a short geological period. So, I mean, a fossil A, it existed for 300 million years. So, this time scale can be defined by this fossil. Alright. Now, what are their characteristics? They are easily recognizable, they exist over a short geological time range, and they are widely distributed. So, first condition, recognition. I mean, they can be easily identified, recognized. Second condition, they should have a short geological extent, but the geographical extent should be wide. Now, getting it, what are index fossils and what are the characteristics of index fossils? In summarizing all these things, index fossils are actually the animals or plant remains that are characteristic of certain geological horizons, that they are called index fossils. They are also called guide fossils or marker fossils. They just, mark a certain geological period. So that's why they are called as index fossils. So though they have limited geological range or vertical distribution, but they have a very wide geographical range or lateral distribution. So they are used in dating and identification of rocks. Moreover, such fossils are restricted to specific rock formations, only a specific rock formation. See, I told you na, like this one, a particular strata, a particular rock formation you find here, maybe fossil A. In this, maybe you find fossil B. So, they are found in particular rock formations. Okay. So, the rocks having index fossils in the different parts of the world can be correlated with each other. And the correlation may be through the study of index fossils, study of fossils assemblage, and study of stages of evolutionary development. Alright, so this is something we saw about index fossils. So the next topic we'll be covering in the next lecture. Thank you so much.